Welcome back, everyone. We're diving into a fascinating paper today called Model Reporting for Certifiable AI, a proposal from merging EU regulation into AI development.
Sounds dense.
It is a bit. But I think as folks already familiar with machine learning and data science, the math behind it all, you'll find this proposal for standardized reporting super interesting.
Oh, so it's like a process thing, not just pure theory.
Exactly. Think of it like a system of cards to document each step as you're developing AI, sort of inspired by those model cards and data cards we see popping up.
Makes sense. Got to track all that stuff somehow. So is this all about that certifiable AI buzzword I keep hearing?
Yep. And the paper really hits on why that's becoming so crucial. As AI gets used in bigger and bigger ways, we need standards and regulations, right?
Totally. But certifying AI, that's got to be way harder than like regular software, right? It's not just about if the code runs.
That's exactly their point. It's
Yeah.
about understanding the data, the potential for bias creeping in, the whole black box problem.
And what happens when the AI makes a decision, good or bad? Lots to unpack there.
They get into all that. Auditing the AI, how to even certify it, what standardization could look like. It's all connected to building AI we can trust.
Which is the million-dollar question these days, isn't it? So are they saying current stuff isn't enough? Like, what about the EU's AI Act or Fraunhofer's assessment catalog?
They're great starting points.
Mm-hmm.
But the paper argues they often lack that really nitty-gritty guidance that developers need. It's a complex landscape.
Okay, I'm seeing where these cards come in now. Hand-holding through the mess.
In a way, yeah. They're meant to guide you step by step, so you're thinking about all these essential things for safe, transparent, accountable AI.
Sounds thorough. How many cards are we talking here?
4. There's the use case card, the data card, the model development card, and finally the model operation card. Covers the whole life cycle.
Nice. So use case, that's got to be about figuring out the problem in the first place, right? Is AI even the right tool here?
That's a big focus. And justifying why you're using AI, that apparently came directly from talking to certification bodies. They want to see that thought process.
Makes sense. Can't just slap AI on everything because it's trendy. Got to prove it's the best solution.
They even suggest looking at past incidents with similar AI applications, like where did things go wrong? Learn from those mistakes.
Ah, so like the AI incident database, that sort of thing.
Exactly. Helps anticipate potential problems before they blow up.
Smart. All right, so onto the data card. This is where we data geeks shine.
Right. This card is all about the data,
Hmm.
collecting it, ensuring the quality is up to snuff, all the pre-processing steps, and of course, documentation, documentation, documentation.
Music to my ears. So it ties into regulations like that EU AI Act we talked about.
Big time. It's not enough to just have mountains of data. It's got to be the right data and handled properly at every stage. Big emphasis on data quality there.
Yeah, makes sense. Garbage in, garbage out, as they say. What about things like bias?
They get into that too, especially when it comes to protected attributes. Got to document potential biases related to that stuff super carefully.
Tricky stuff. And then there's the age-old question. How much data is enough?
They address that head on. Apparently, there's often this logarithmic performance improvement with more data. So gains shrink as your data set gets bigger.
Diminishing returns, yeah. We've all seen that performance curve plateau.
They suggest watching that curve to estimate how much data you really need. Find that sweet spot where improvement flattens out.
Pragmatic. Any rules of thumb mentioned?
They brought up the 1 in 10 rule. Basically, estimate your data set size relative to the number of parameters in your model. It's a starting point, at least.
Interesting. And I'm guessing metadata is crucial here, too.
Huge. Especially for those protected attributes we mentioned. You'll use that for stratification, creating test sets with varying difficulty, all that good stuff.
Got to make sure your model's tested on a diverse range of examples, right? Speaking of test sets, how do they approach figuring out the right size for those?
Now, this is cool. They bring in a statistical significance perspective, like what we see in medical research. Error margins, confidence levels, the whole 9 yards.
So it's not just about grabbing some arbitrary percentage of the data, it's more nuanced than that.
Way more. They even talk about test variance as a clue. If you see high variance across different runs, your test set might be too small.
Huh, never thought about it that way. Makes sense, though. Consistent results are what we're after.
And all throughout this data stuff, they hammer home the importance of domain experts.
Of course. They're the ones who truly understand the nuances.
Exactly. They define edge cases, point out iffy samples for data quality documentation. Can't do this in a vacuum.
All right, so we've got our problem defined, our data prepped. Time to build the model, right? Bring on the model development card.
That's where we're headed. This one gets into the nitty-gritty of model selection, feature engineering, hyperparameter tuning, all the technical fun.
And I bet explainability is a big focus here.
Huge E. They stress figuring out your explainability needs right up front. Do you need local explanations for each decision or a global understanding of the model's behavior?
That's a good point. That choice probably impacts your whole approach, from model selection to data prep.
Exactly. And it's not something you tack on at the end. It's got to be baked in from the start.
Yeah.
They also talk about comparing your model to those standard baselines. Make sure it's actually adding value.
Right, like, is a fancy deep neural net really necessary, or would a simpler model do the trick? Occam's razor and all that.
They bring that up. Simpler is often better if performance is comparable. Easier to interpret, easier to trust.
Always a win. What else do they highlight on this card?
Defining minimum acceptable scores for your evaluation metrics. And this should be done with input from domain experts, so it's grounded in real-world needs.
Makes sense. Gotta set the bar somewhere. And I'm guessing data leakage during hyperparameter tuning is a big no-no.
Oh yeah, they go there. They emphasize locking that test set down, using techniques like k-fold cross-validation to avoid inflating your performance estimates.
Solid advice. We've all seen those suspiciously good results that turn out to be a data leak in disguise. Anything else stand out?
Model confidence calibration, making sure the model's confidence scores actually match how likely it is to be right. Techniques like conformal prediction come up here.
So not just aiming for high accuracy, but also for accurate uncertainty estimates. That's robust AI.
Exactly. And they finish this card by hammering home the importance of real-world testing. Simulations can only take you so far.
Absolutely. Gotta see how it performs in the wild with all its messy unpredictability. And that brings us to the final card, right? Model operation.
That's where we're headed. This card is all about keeping that AI system running smoothly and safely once it's out in the real world. The long game.
I'm all ears. What are some of the key ideas they focus on there?
They talk about needing a really detailed operating concept,
Right.
like outlining all the software components, APIs, IT security measures, the works.
Sounds like they're bringing in best practices from traditional software engineering, treating AI systems with the same level of rigor.
Exactly. And, of course, they touch on that post-market monitoring system that the EU AI Act is pushing for. Got to keep an eye on things, make sure the system's still behaving.
So it's not set it and forget it. You need active monitoring, periodic checks, the whole shebang.
Absolutely. They even suggest a user interface that provides different levels of transparency, depending on who's looking. High-level summaries for the operations folks, detailed metrics and logs for the data scientists.
Transparency is key for building trust. Everyone needs to understand what's going on at the appropriate level. Did they talk about model drift at all?
Yep. They acknowledge that things change, right? Data drifts, the environment changes. Got to keep an eye on how that affects the model's performance over time.
Makes sense. A model trained on yesterday's data might not cut it tomorrow. Did they mention any specific techniques for detecting drift?
They mentioned using F-divergence to compare the data distribution in the live environment to what the model is trained on. See how much things have shifted.
Smart. And of course, no discussion of model operation would be complete without a nod to privacy.
They cover that too. GDPR compliance, using things like differential privacy for anonymization. Got to protect that sensitive information.
Absolutely crucial. And what about keeping the whole system stable and secure once it's in production? Any tips there?
They're big on well-defined MLOps practices, version control, update procedures, testing periods, rollback mechanisms. Basically, all the good stuff from software engineering applied to AI.
Sounds like a comprehensive approach. It's about treating AI systems like the complex software systems they are.
Exactly. They wrap up the whole framework with a really interesting example, a toy audit of a bicycle manufacturer using AI for quality inspection.
Oh, the toy audit. I was wondering about that. Let's hear it. I'm curious to see how these cards actually play out in a real-world scenario.
Let's dive in.
So this toy audit, it's like a walkthrough, right? Shows us how to use these cards in the real world.
Exactly. A hands-on example. So let's start with that use case card.
Yeah.
What's the story here with this bike manufacturer?
Okay. So they're using AI for quality control on carbon fiber bike frames. The use case card lays out why they chose AI over, like, manual inspection.
Makes sense. Carbon fiber's tricky stuff, right?
Yeah.
Lots of intricate details. Humans can miss things.
That's their point. Manual inspection is subjective, prone to errors, especially with something where safety is a concern.
Yeah. You don't want a faulty bike frame going out the door. Big consequences. Did they talk about those risks in the card?
Oh, yeah. The big one is a false negative. The AI says the frame's good, but it's actually defective. Could lead to accidents, injuries, bad news.
So they know the stakes. Reliability is key here. What about the data side of things? How'd they handle that?
The data card gets into all that. They talk about how they collected the images of the bike frames, making sure the data set is representative of all the different models they make, the potential defects, the whole shebang.
So it's not just quantity, it's quality and coverage,
Right.
right? Got to match the real-world variety of frames. How to do that?
Stratified sampling, for one, making sure different bike models, batches, types of defects, it's all proportionally represented in the data.
Smart. Did they do any data augmentation? I feel like
Mhm.
that's almost essential these days.
Yep, especially for those rarer defects. Got to pump up the data set somehow. And of course, they talk about preventing data leakage.
Crucial, especially when you're splitting into training and test sets, can really skew those performance results if you're not careful.
They seem to have taken all the right precautions. So, onto the model development card. What kind of AI magic are they using here?
Deep convolutional neural network. Pretty standard for image classification these days.
Makes sense. Those things are beasts when it comes to images. What about the metrics? How are they judging this model's performance?
They focus on metrics that matter for the task, right? Recall, precision, things that directly relate to finding those defects.
Yeah.
So it's not just about overall accuracy, it's about minimizing those false positives and negatives that could have real-world consequences. Did they have any specific targets in mind?
Yeah, they were aiming for 99% recall. They want to catch almost every single defect.
That's ambitious. But with safety on the line, I get it. What about explainability? Those deep learning models can be black boxes.
They acknowledged that, but they did use techniques like saliency maps, heat maps, to highlight the areas the model's focusing on when making decisions.
It's a start, right? Gives the operator some insight into what the AI is thinking. Okay, what about the model operation card? What happens once this thing is out in the factory?
Monitoring, lots and lots of monitoring. They talk about tracking performance metrics in real time, watching for any signs of drift.
Drift. That's where the model's performance starts to degrade over time,
Mm.
right? The data changes, the environment changes. Yeah. Got to stay on top of that.
Exactly. They have a separate set of labeled data, never seen by the model before, to continuously evaluate how it's doing.
So like a constant health check. What happens if they see those warning signs, the performance dropping?
Retraining. They grab new data, reflecting the current state of things, and update the model. Maybe even bring in some ensemble methods for extra robustness.
So they're prepared to adapt. It's not a static system. It's constantly evolving.
Mm.
What about the people running this thing, the operators on the factory floor?
Training, training, training. Got to make sure they understand the AI system, its strengths, its limitations, how to use the interface.
Can't just throw tech at people and expect it to work, right?
Yeah.
You need to be comfortable with it.
Exactly. And for transparency, they use those saliency maps we talked about, shows the operators what the AI is looking at when it flags a defect.
Visuals are powerful. Makes it easier to trust the system when you see what it's basing its decisions on. Any surprises during real-world testing?
Actually, yeah, they ran into problems with lighting conditions in the factory, stuff they hadn't fully accounted for in the training data.
The real world always throws you curveballs. Even with the best data collection, there are always going to be those edge cases, what they do.
More data. They went back, gathered images specifically targeting those tricky lighting scenarios, retrained the model.
Classic. Iterate, adapt, overcome. That's AI development in a nutshell. This toy audit is a great illustration, really brings those cards to life. Wow, what a journey through these cards. Really changes how you think about developing AI.
It's not just about performance anymore, right? It's about building systems we can actually trust that make sense, that are ethically sound.
And these cards, they're like a checklist, making sure you're thinking about all that stuff at each step. Super valuable as AI gets more complex.
Totally. And even though regulations and certifications are still being figured out, this paper gives us some real tools to deal with those challenges, especially as AI starts being used in those high-stakes applications.
It's an exciting time for sure, but also a time to be careful, to be responsible with this tech. This framework helps us build AI that benefits everyone.
Couldn't agree more. To everyone listening, seriously, dig into those resources the paper mentions, stay up to date on this certifiable AI stuff, and think about how these principles apply to your own work.
Even if you're not building super critical systems, thinking about explainability, data quality, all that, it just makes your AI better.
Yep.
Raises the bar for the whole field.
Absolutely. As AI becomes more and more part of our lives, we have to prioritize safety, transparency, accountability. The future of AI depends on it.
Well said. This has been a fascinating deep dive into certifiable AI. Until next time, folks, keep learning, keep innovating, and keep pushing the boundaries of AI, but do it responsibly.